This is the James Webb Space Telescope. It is the largest, most powerful space observatory ever built, designed to peer back over 13 billion years to see the first stars and galaxies forming. But to launch this massive machine into space, engineers faced a monumental challenge. The telescope is far too large to fit inside any existing rocket. To solve this, they built it like a giant piece of origami, folding it up to fit inside the nose cone of a rocket, and then unfolding it step by step in deep space. Today, we're exploring the mechanical masterpiece of the James Webb Space Telescope and the exact sequence of how it unfolded. Let's start with the scale. Fully deployed, the telescope is dominated by its massive sunshield, which is about the size of a tennis court. It stretches 69 feet, or 21 meters long, and 46 feet, or 14 meters wide. Above it is the primary mirror, measuring over 21 feet, or 6.5 meters across, made of 18 gold-plated hexagonal segments. The entire spacecraft stands 39 feet tall and weighs more than 6 tons. Because the Ariane 5 rocket's cargo area is only 17 feet wide, the telescope had to be folded with extreme precision. The unfolding process took place over 14 days as the telescope traveled to its final destination, 1 million miles from Earth. There were 344 single points of failure. If any of these mechanical releases or hinges failed, the telescope would be useless. Here is how the sequence worked. Just 30 minutes after launch, the solar array deployed to generate power. Next, the high-gain antenna unfolded to establish communications with mission control. On the third day, the real drama began with the deployment of the sunshield. 2 large pallets holding the sunshield membranes lowered into place. To separate the hot spacecraft bus from the cold scientific instruments, the deployable tower assembly extended, lifting the mirrors and instruments 4 feet, or 1.2 meters away from the base. On the 5th day, protective covers rolled back, exposing the 5 layers of Kapton. The sunshield is not just one thick barrier. It consists of 5 separate layers, each thinner than a human hair, separated by vacuum gaps. To pull these layers outward, 2 mid-booms extended on the sides, pulling the membrane into a giant kite shape. Then came the most delicate part, tensioning. The 5 layers must be separated and tensioned individually. A complex network of 90 cables, driven by electric motors and guided by pulleys, pulled each layer tight, starting with the bottom layer closest to the sun. This created the critical insulation gap that allows heat to escape out the sides. With the sunshield fully deployed, the telescope could finally cool down. Next, the optical components had to be assembled. On the 10th day, the secondary mirror support structure unfolded. This is a 24-foot or 7.3-meter tripod holding the secondary mirror directly in front of the primary mirror. Following this, the primary mirror itself had to be completed. The mirror has 2 side wings, each holding 3 hexagonal segments. On the 12th day, the left wing swung forward and locked into place. The right wing followed the next day. Even though the wings were locked, the telescope was not yet ready. The 18 gold-plated hexagons had to work as a single perfect mirror. Behind each segment are 7 tiny actuators, which are mechanical motors. These actuators can move the mirror segments in increments of just 10 nanometers, about 1/10,000th the width of a human hair. Over several months, engineers aligned the segments until they focused light perfectly into the instruments. The physics behind this design is remarkable. The sunshield keeps the mirrors and instruments at a freezing minus 388 degrees Fahrenheit, or minus 233 degrees Celsius, which is essential for detecting faint infrared light from the early universe. Meanwhile, the hot side of the spacecraft, facing the sun, operates at a warm 185 degrees Fahrenheit, or 85 degrees Celsius. The James Webb Space Telescope is a triumph of modern engineering. By folding a giant observatory into a rocket, humanity gained a new set of eyes on the cosmos. Even now, it is sending back images that redefine our understanding of space. If you enjoyed this video, hit that subscribe button and the bell so you're notified when I post new content. Stay connected and be part of the journey. Follow Build from Scratch. Thank you for watching. I hope you learned a lot, and I'll see you next time.